and I'm Vinka Craver. I'm a professor of civil and environmental engineering, and I'm also the associate dean for research for the College of Engineering. And I wanted to talk a little bit about that, reinforcing all this concept of circularity in textiles. But let me talk a little bit about how I got interested on this area. I'm a wastewater engineering and a solid water engineer too. So I always had been interested about the concept of waste. Because as we think about it, in the case of a textile, think about a teacher, we use so much energy and resources to create that teacher when there's going to end up in little fibers in a wastewater, or it's going to be going to a landfill or even incinerated. So I think a lot of garbage engineers like me, sometimes they will tell you that there's no such a thing as waste. But so what is waste? And I think Carl already gave a little bit out my punchline here, that waste is a resource that usually is going to be at the wrong place and at the wrong time. And let me tell you why I think this is happening. Is because traditionally we have this linear approach to develop our technological processes. We have raw materials that go through manufacturing, they go to use, and then they end up in the landfill. Unfortunately, most of these stages, they don't recognize the interaction that they have between them. And we only see that interaction when there are some problems. I bet you're all familiar with the supply chain, that it really taught us how some of these stages are connected. So changes that we do in one stage are going to certainly have repercussions in the other phases. So this is what we do in my lab. We try to understand what are that interconnections. And when we are changing something in any of the stages, we want to know how the resources that we're taking from nature and how the emissions that they are going to be released are going to be changing in each one of these phases. Now, we call this a life cycle approach. Now today you are hearing about this circularity, bring all these linear systems into a circular manner. Hopefully that will allow us to understand better, each phases will feel in some way other phases. Changes that happen in one are going to be directly connected to the other ones. Certainly it's going to be important, again, to use this life cycle approach to understand how the input and output in this circle is going to be happening with the environment. But also, we have to recognize that our technosphere that are going to be created is going to be connected with an economical system, with a societal system, and with the environment. Changes in manufacturing practices are going to change the market. Also are going to change the demand for workforce. And certainly it's going to change, the exchanges of materials in the environment. So now I don't want for you to live here thinking, oh, Vinka complicated the thing so much, I don't want to start thinking about a solution. Because like everybody was saying here, this is an opportunity for everybody in this room to get together and recognize that we are in a life cycle and in a system, and this system is dynamic. Changes that we do in one phase are going to be felt by the other phases. And also for all the innovators that are in the back of the room with incredibly new processes, I think using this approach, the system thinking and life cycle approach, it's an opportunity for early stages of design, because in the early stages of design, you're going to be more versatile. You can do more changes in comparison to a full-scale process, which is going to be more costly, more difficult to change. So I just want to give another shout out to the Plastic Collab, in which we have expertise, in all these different areas, and we are really interested to connect with all these different stakeholders and start reinforcing the circular system that we are proposing to you. And with that, I just want to thank the opportunity to be talking here. So, thank you.